Okay, so what we're going to do is find an equation that goes through this point, -2, 3, and is parallel to this line. Okay, now the key is parallel. So if we look at this line, we know that an equation parallel to it will have the same slope as this line, which means we know already, before doing almost anything, that our equation is going to look like y equals 2x plus, we don't know where it's going to go through, so we'll call it b. Okay? B standing for where on the y-intercept is this going to be. So what we do have is we have this point, -2 and 3. This -2 stands for the x value. So -2 is the x value, and y is the y value of that point. So what we can do is we can take these values and plug them into the equation. So where we have the value of y, we can put it in for y. Equals 2 for the slope of 2, and x -2, because that is the x value for this point. This is the x, this is the y, right? The left, right, the up, down. The x-axis along here, the y-axis along here. Okay, now what we don't know is where it will go through on the line, so we'll just keep that as a b, just like if we had that value x. Remember, you can name a variable any letter you want. So let's just do the math, the algebra. 3 equals 2 times -2. Negative times a positive is a -4 plus b. To get b by itself, we add 4 to both sides. 3 plus 4 equals 7. B equals 7. Okay, so now what we do, look, we had everything in this original equation. All we have to do now is add the y-intercept, or the b. Y equals 2x plus 7. Let's kind of check it out. So if the y-intercept is 7, that means it's going to 5, 6, 7. It's going to go through here. It's going to go through that point. Let's see if we have a way to make a line. I believe this is it. So if we have one going here. Oops. Let's try that again. So point starting here. Oops. Let's try that again. Okay. Point starting here. It goes through this line. Just keep it going. And these look parallel. They have the same, let me just put an arrow on that to show that it goes on forever. They look parallel. They have the same slope, 2, slope of 2. They are parallel lines. Excellent. Now what we're going to do, now we're going to look at a very similar question with a slight difference. So this question is asking us, how do you find an equation of a line that goes to the point 4, 3 and is perpendicular to y equals negative 3x minus 2. So I circled that perpendicular. So we're going to start out the same way. We're going to write our little equation. We know it's going to be the y equals some slope x plus the y-intercept, where along this line it crosses. So what is that slope going to be? The slope for this line equals negative 3. What would the slope of a line perpendicular to it, line perpendicular to this one, be? Remember, we call it the inverse, or we call it the opposite reciprocal. So the opposite means we go from negative to positive. And reciprocal means we flip this number. Well, if you remember, negative 3 is the same as negative 3 over 1. It's basically, if you have whole things, like if you have a whole pizza, you have negative 3 means you have negative 3 whole pizzas, which also doesn't make sense. Or you owe somebody 3 pizzas, right? Okay. So we flip that over and we get 1/3. So opposite, so negative to positive, reciprocal, we flip it. Negative 3 over 1 to 1 over 3. So this number here, or the slope, will be positive 1/3. Now we do the same thing we did in the last question. Our 4 is the x value because we go right 4 spaces. Our y is 3. The first number is always x, the second number is always y. And now we just substitute again. So our y is 3, so let's put that. 3 equals, we have 1/3 as the slope of this line. X, our x value we determined was 4 of the point. And our y-intercept is unknown. So, first, let's multiply these. 4 times 1/3 is 4/3 plus b equals 3. Now, we have to subtract 4/3 from each side. So let's just see what we have. We have b equals 3 minus 4/3. How do we do that? Well, honestly, we can make them both thirds, right? If we have the same common denominator, we can subtract. To do that, let's put this over imaginary 1. And let's multiply both fractions by 3 over 3. Why is that allowed? Because 3 over 3 is just multiplying it by 1. You can always multiply something by 1 because it really doesn't change the structure. It just changes how we think of the number 3. So instead of thinking as 3 pizzas, 3 whole pizzas, now we're going to think of it as 9 slices, and every 3 slices is a whole piece. So we have 9 slices of pizza, 3 slices a piece, so we still have 3 pizzas, right? Now we have 12. Oh, oops, I messed up. I made a mistake, which happens all the time. We'll learn from mistakes. That's the name of the game. Part of the mission statement. So, I'm not going to multiply this by 3 over 3 because we already have 3 on the bottom. So by multiplying it by 3, I made them different, and we want them the same. Okay, so I'm just going to keep it 4/3 because we want thirds, right? 3 and 3 equals b. I haven't done anything with that side. So now 9, the same denominators. So we can just do 9 minus 4. 9 minus 4 is 5. 5/3 equals b. Excellent. So our equation, we have to go back to this one, right? So y equals, same, the slope is what we talk about, 1/3 x plus, and now we have 5/3 b. Which means 5/3 is is 1 and 2/3. So if we go up to 1 and 2/3, it's going to actually meet it very close to the y-intercept of the other. And then it's going to go up 1 over 3, up 1 over 3. So it's going to be it's a more complicated one to graph, or a little harder to graph perfectly. 1, make sure we still have that line. Okay, I think I do. And let's just connect. Excellent. At 1, it looks pretty dang much like a right angle, which isn't proof. Remember, looks aren't proof. But we know the equation is the opposite reciprocal, but that gives us, we did well. Good job.